The Empirical Rule by Amber F. Stats 300, Professor Rojas. The empirical rule states for a normal distribution to occur that 68% of the data will fall within one standard deviation of the mean, 95% of the data will fall within 2 standard deviations of the mean, and 99.7% of the data will fall within 3 standard deviations of the mean. The empirical rule is also known as the 68, 95, 99.7 rule. The reason these numbers are important to remember is because if you have these 3 numbers memorized, you can calculate any normal distribution because it will always add up to 100%. Here we have a normally distributed curve. Our mean is right in the middle, and each one of these lines represents one standard deviation. 1, 2, 3. Same for the other side of the mean. 1, 2, 3. We have our outliers on this side, our inflection point where the curve begins to increase, and another inflection point here where it begins to decrease. And we have to remember that more than 2 standard deviations of the mean means that our data is unusual. Let's practice. A machine fills 12 ounces of honey into a jar for a beekeeper. Not all of the jars of honey, excluding the weight of the jar, weigh exactly 12 ounces. The weight of the honey is placed normally distributed with a mean of 12.4 ounces and with a standard deviation of 0.2 ounces. We'll read through the questions and then answer them together on the next page. First, we have to ask why we can use the empirical rule. And it was stated that it is normally distributed. So we'll begin using the empirical rule. 2, if you purchase a jar filled with honey, what is the likelihood percentage it has less than 12 ounces? 3, if you purchase a jar, what is the likelihood it has more than 12.2 ounces? And 4, would it be unusual for a jar of honey to weigh 12.9 ounces? First thing we need to do is draw our normal curve. Find our mean, which was given to us, 12.4. Our standard deviation of 0.2. We begin with 12.4. Add 0.2, that gives us 12.6. Add another standard deviation, that gives us 12.8. And another, 13. We do the same thing on the left side, except for we subtract the standard deviation. 12.4 minus 0.2 gives us 12.2, and so on. We still need to remember the 68, 95, 99 rule to conclude all of our percentages up here. Going back to the question, what is the likelihood of the honey jar having less than 12 ounces? First thing that we do is find 12 ounces, and everything that is less than 12 ounces means that we calculate 2.35% added to 1.5%. Sorry, 0.15. And that gives us the likelihood that the jar of honey will be less than 12 ounces is 2.5%. 3, what is the likelihood the jar has more than 12.2 ounces? We go back over to our curve, we find 12.2 ounces, and the question is asking for more than, so we take 34% plus 34% plus 13.5 plus 2.35, and then we also add 0.15, and that gives us a total of 84% likelihood that the jar has more than 12.2 ounces. And our last question, would it be unusual for a jar to weigh 12.9 ounces? 12.9 falls about here, which is, as we learned earlier, more than 2 standard deviations of the mean, which is yes. It is unusual for a jar to weigh 12.9 ounces because it's more than 2 standard deviations of the mean. Thank you for listening to my video. Good luck studying, and just remember 68, 95, 99.